Hello dear young minds, welcome back to PhysicsPoint. In this video, we will see at the concept of force, thrust and pressure. Alright, so what is the meaning of all these words? We'll have complete idea in this fifth video of the chapter Gravitation. My name is Shrikant Bashetti. I welcome all of you to your beautiful physics channel PhysicsPoint. Alright, so what is this force? Already you know about this force, right? What is the symbol for this force? The symbol is force. Can somebody tell me what is the definition for force? Yes, already you have studied it in your force and laws of motion, right? It's a quantity which changes the state of motion of a body. Okay, all right, this is a different approach. Already we have studied that this force is directly proportional to rate of change of momentum. All right, so you know this. Then here m is taken common. This is v minus u divided by t. All right, then we are going to have f is proportional to ma. All right, then we'll have f is equal to kma. In SI system, this k value is 1, then f is equal to ma. So this is Newton's second law of motion. No, this entire thing, whatever I am marking red right now. So this is the Newton's second law of motion. All that you know, you have idea about all these things, right? And what is the unit of force? The unit of force is Newton. You know about that also, right? So what is the unit? The unit of force is Newton. So the main concentration is not on force right now. Alright, so we are going to study about one word that is called as a thrust. Okay, what is this thrust? So it's quite simple definition, that is perpendicular force on a body. What is this? Perpendicular force on a body is called thrust. Okay, for example, I have got one body here. Okay, this is the body and we are applying the force like this. Is it a thrust? Definitely this is the force, we know that. Is it thrust? Yes. Why? Because it is acting perpendicularly. Alright, the same body, for example, the same body is here, we are applying the force like this. Is it thrust? Yes. Again it is acting perpendicularly. So that's why this is also thrust. Alright, so for example, we have the same body, we are applying the force like this now. Is it thrust now? No. So definitely this is a thrust, 100% this is thrust, and this is also thrust, because look at this, they are acting perpendicular. Alright, so look at this, perpendicularly it is acting, but here it is not perpendicular, here it is not equal to 90 degree, correct? No, so that's why definitely this do not come under the category of thrust. Alright, I hope the meaning of thrust is quite clear. Now let us have a look at this word pressure. If you say the symbol for pressure is P, we know that, and if you say P is equal to F divided by A, force per unit area, this becomes wrong. This is completely wrong. This definition, force per unit area, is completely wrong. Okay, pressure is nothing but perpendicular force. What is this? Perpendicular force we have to take. Perpendicular force per unit area. Perpendicular force per unit area. Or you can just call another definition, you can say one more definition, that is called as thrust, because perpendicular force means thrust only. So thrust per unit area. Thrust per unit area is known as pressure. So for pressure we are going to write the definition, that is like perpendicular force. F perpendicular means perpendicular force per unit area, or you can write it as thrust divided by area. Like this also you can write the definition. So this formula will be correct. Okay, this formula is wrong. Directly you cannot say force per unit area. Alright, now what is the unit of this pressure? What is the unit of pressure? Look at this. Now this perpendicular force means this is Newton only, no? So this is Newton per meter square, and this is only known as Pascal. Pascal was a scientist. To pay respect to him, this Newton per meter square is named as Pascal, and usually we represent it as PA. Okay, whenever we are saying pressure, we'll be saying it as 5 Pascal, okay, or 0.5 Pascal. Pascal is nothing but Newton per meter square. Alright, the concept of pressure is also quite clear. Let us see some of the examples. Okay, why this pressure is quite important for us to study this Archimedes principle, fluid pressure and all in the coming classes. So that's why let us see some of the examples. Look here, what is happening here? There is one wooden block, and let us take this as the some rubber head. Okay, so this force is being acted on this rubber head, right? So how much force is acting? Now let us take some force is acting on this. Let us take this force to be 100 Newton. Okay, just example I'm taking. And what about area about this is the area, right? I mean, I'm not able to show that side also. You can see here, this is the area, right? Whatever area is here, it is written as area also. Whatever area is here, the same area will be here also. All right, let us take this area to be let us take 2 meters square, just an example. Okay, 100 Newton. How this force is there? Definitely this force is acting perpendicular. Look at this, perpendicularly it is acting, no? Definitely at 90 degree it is acting. Now if you want to find out the pressure, pressure is equal to, what is the formula? Perpendicular force divided by area. What is the perpendicular force? That is 100 Newton. And what is the area? That is 2 meters square. 2 ones are 250s are, so that's why it becomes 50 Newton per meter square. And definitely you can write that as 50 Pascal also. So pressure is going to be 50 Pascal. Please remember, while taking the pressure, you must take perpendicular force. That's very, very important. All right. Moving forward, now how this pressure is dependent on? Pressure is equal to, we are writing perpendicular force divided by area, and how much force we apply, it is in our hand. Okay, how much area is there, that depends on the object, no? So we can say that this pressure is inversely proportional to area. Okay, if you are increasing the area, the pressure will decrease. Okay, and if you are decreasing the area, the pressure will increase. Look at this inversely proportional meaning. What is the meaning of that? If you are increasing, the pressure should decrease. If you are decreasing this, the pressure should increase. So we'll see some of the illustrations here. For example, you see here this person. So this person is standing on this sand, right? I mean, he's walking. Now, what is the force he is applying on this sand? That is his weight, right? So how much force he will be applying? So whatever weight he has weight, right? Weight is equal to mg. If you don't have idea about weight, then go back to the previous videos and see that and come back to this video. Okay, this is perpendicular force for sure. This weight itself is known as a perpendicular force. Alright, and what is the area? Look at this, whatever his feet are there, no, how much area it is covering, and that is the area. On that much area he is applying the force. So that's why here the formula for this pressure will be weight divided by area, correct? No, now look at this. I mean, the same person, let us assume the same person is here. Okay, he is lying, he is sleeping on the sand. Now his area has increased or not. Look at this, the force applied by this person on the sand is same. So that weight is equal to mg. Okay, that is there for sure. That weight, whatever weight is there, that is equal to mg for sure. But how about the area he is exposed to? Look at this area. So wherever he is sleeping, so for that much area he is exposed, no? For this complete area he is exposed. Alright, look at this, complete area he is exposed for this complete area. So here also the pressure will be weight per unit area, but his weight do not change, it remains constant. Here also same weight, here also same weight. The same person is there, no? But here the area is less, so that's why pressure is more. That's why his feet will be going little deep into the sand, correct? No, because more pressure is there. This pressure is more. Here the area his body is exposed to is more, right? Because more area here. So that's why pressure will be less. So that's why his body do not go deep. Do not go deep. Okay, you must have observed this in the beach side. If you are standing, means your feet will go a little bit deep inside the sand, but if you are sleeping, means that won't go too much deep. It will go little bit into the sand, but not that much deep as it is going in the feet thing. Alright, I hope it is clear. So if you are decreasing the area, pressure will increase. Already I told you. Let us take some more illustrations. Now look at this. Look at these illustrations, whatever I am showing you here. Now if you observe this, this is a nail, right? Now the ends of the nail are made very sharp, right? ends of nails, ends of nails, okay, not the other end, not this end, this end, okay, here this end. So ends of the nails are sharp. Why they are sharp? They are pointed. Rather than saying sharp, you can say them as pointed. Why? Because here less area they are exposed to. If less area they are exposed to, then how about pressure? Definitely the value of pressure will increase, and it can go easily inside this wooden block. Now head of this nail, whatever this head is there, now look at this head, this is the head of the nail, no, this head of the nail area is more. Why? So that you feel less pressure on your finger. Look at this, your finger is exposed to how much area? This much area, big area. Look at this nail, the head of this nail is made usually bigger one, no. Why it is made bigger one? So that it has more area and you feel less pressure. The nail should not go into your hand from this side, okay, you feel less pressure, and that's why you are safe, and this will be going inside. You can see here also, these are some of the pins we use on notice board and all, no. So why these are made so much big? Why? Because the area is more and pressure is less, and you are safe. How about this? This is pointed end, no. This is a pointed end, so here area is less, the pressure will be more. Alright, so that it can go easily inside the notice board. Look at this pin also here. Look at that another end. So here the area is less, pressure is more. That's why it goes easily into the notice board. Now how about this? This side the area is more and pressure is less. That's why you are safe. Alright, nothing will happen to your hand. Now which one is very easier? This kind of pin, this is very easy, or this is very easy? This is more easier, no? Why? Because you have more area here, you are safe. Here you have less area again compared to this. This head is having less area, here this head is having more area. This is a little difficult. Okay, I am not saying this is easy. Okay, this is little difficult. Okay, bit difficult it will be. Compared, if you compare this one and this one, it will be little easy, and this will be little difficult. Alright, fine then. Now look at this. When they are taking blood samples and all, they will be having this needle, right, which is having this pointed end. Why? So that with less amount of force, if you just apply small amount of force also, even though this force is small, this area is also less, right? Whatever this area is there, this area is also less. So this area is less means pressure will be more, and immediately they can take the blood sample. Alright, I hope the concept is getting clear. So the main motto is to say, if area is less, pressure is more. If area is more, look at this example. This is the camel's feet, no? So what is this? This is the camel's feet. Okay, this camel's feet is very much wide. Alright, this is wide. What is the meaning of wide? This is having more area. More area means it applies less pressure. It applies less pressure on the sand, less pressure on sand. So that's why it goes little deep. It won't go much deep into the sand. So camel can walk easily. Camel can walk easily in sand. Easily in sand. If somebody asks you a question, why camels can walk easily in sand? Okay, you have to say camels have wide feet. That means more area is there, so less pressure on sand they apply. So that's why they can walk easily on sand. If somebody asks you why camels' feet are wider, why they are wider, if they ask you, you have to say if they are wide means the area is more and less pressure they apply on the sand, so that they can walk easily in the sand. Alright, so this kind of question can be framed. What is the question? Why do camels have wide feet? And how do camels walk in the sand? It becomes quite difficult for us to walk in the sand, no? Because our feet area is quite less compared to this feet. Look at this feet, this is camel's feet. And how about this? This is our feet. Our feet is having less area. Okay, less area is there, that's why more pressure. So that's why our sand go deep into the sand. We feel difficult to walk in the sand, in the desert. But camel can easily walk in the sand as it is having wide feet. Alright, fine then. So these were some of the illustrations. Let us get into some of the numericals and see them. What is this numerical? The numerical goes like this. A wooden block of dimensions 2 meter into 4 meter into 5 meter. So this is like, this is length, this is breadth, and this is height. Alright. So it is placed on a table with the face of dimensions 2 meter into 5 meter touching the table. Alright. This can be, this wooden block is there, no, it can be kept in 3 combination, that is length and breadth touching the table, or breadth and height, or length and height. So 1, 2, this is first combination, 2 and 4, 4 and 5 is second combination, and 5 and 2 is third combination. So like that 2 meter, that is like length into height, that is 5 meter. So they are keeping this like this on the table. Let us take, this is a table, okay. Here is the table. So let us draw one table like this, okay. So just simply I am showing here. On this they have placed, okay, okay, on this they have placed one object. They have placed one object which is having dimensions, this is like 2 meter, this is 2, and this is 5. Alright, what is the mass of this? The mass is also given, right? So what is the mass of this? The mass of this wooden block is, find pressure on the table if mass of the wooden block is 5 kg. So mass is 5 kg, means what is its weight? Weight will be acting downwards, no? You know about this weight, no? So this weight will be acting downwards, and this downward weight, whatever it is acting, that is only known as a perpendicular force. So that is equal to mg. So m is like 5 and g value is 10. So that is like 50 Newton. So this is the perpendicular force. Now how much area it is exposed to? It is exposed to area 2 meter into 5 meter. So that is like 2 into 5 is equal to 10 meter square. Now easily you can find out the pressure. So pressure is equal to, you can write weight per unit area, or you can write this as perpendicular force per unit area also. There is no issue in that. So how much is that? 50 then divided by 10. Alright, so 0, 0 get cancelled. So it has to be 5 Pascal. Alright, this is quite a simple question. Let us move to next question. The question goes like this. A person of mass 50 kg sleeps on ground covering an area of 2.5 meter into 2 meter. What do you mean by 2.5 into 2 meter? I mean this area you can easily find out, no? Length is 2.5 meter. He is covering a length of 2.5 meter and breadth of 2 meter. Now they are asking about pressure on the ground. Alright. So what is this? The mass of this person is 50 kg. Alright. And he is covering an area of 2.5 into 2 meter. That is like 2.5 into 2 is 5 meter square. Alright. Now they are asking about pressure. You know about this, no? Pressure is equal to what? Weight divided by area, or weight is nothing but perpendicular force. What is this weight? mg divided by the area. What is mg? 50 into 10 divided by, what is this area? 5. So this is like 5 ones are 5 tens are 10 into 10 is 100 Pascal. Look at this. So you got the value of pressure. This is the value. Alright, I hope you are understanding what I am trying to say. Basically the main motto of this video is to say pressure is equal to perpendicular force divided by area. This perpendicular force is nothing but this is only known as a thrust. Alright, if you decrease the area, the pressure will increase. If you increase the area, the pressure will decrease. Alright, so many types of questions can be asked from the illustrations. Why camels have larger feet? Why the needles are made with pointed ends? Alright, I mean they may ask about this question also, about this notice board pins. Alright, and any numerical, why our feet go deep inside the sand when we are standing, and why we don't go deep inside the sand when we are sleeping on the sand. So these kind of questions can be asked. And what is the meaning of thrust? Okay, this thrust, what is the meaning of thrust? Okay, force you know already. What is the definition of pressure? What is the unit of pressure? Like that. And numericals, these kind of numerical, simple numericals can be asked. There are so many numericals in your textbook, you try them also. Alright, fine then. So the main motto of this video is completed. If you are liking all these videos, make it sure that you give it a thumbs up, share these videos with your friends, and don't forget to subscribe, because your subscription is the motivation for us to shoot much more videos like this. Thank you very much. Have a good day, and bye-bye.